Hello, in this lecture we will find out the radius of the circle. In the drawing we have a big semicircle and two small semicircles. Inside the big semicircle we have two semicircles and one circle. We know that this line segment equals to 140 units in its length, and this line segment equals to 70 units in its length. Our mission is to find out the radius of this circle. Okay, so first of all, we will define the radius of the biggest semicircle as capital R. So I write it down. Capital R is the radius of the biggest semicircle. Capital R is the radius of the biggest semicircle, and small r will be the radius of the circle. Small r is the radius of the circle. So small r is the radius that we are looking for. We will give names to the different points here. This point will be defined as A. It is actually the touching point of this semicircle with the biggest semicircle. We will define the center of this semicircle as B. The touching point of those two semicircles will be defined as C. We will define the center of the biggest semicircle as O. This point will be defined as O. We will define the center of the smallest semicircle as E. Here, the touching point of the smallest semicircle with the biggest semicircle will be defined as F. The touching point of the circle with this semicircle will be defined as G. The touching point of this circle with the smallest semicircle will be defined as H. And finally, the touching point of this circle with the biggest semicircle will be defined as I. Okay, so line segment AF is the diameter of the biggest semicircle. So I will write it down. AF is the diameter of the biggest semicircle the diameter of any semicircle is equal to 2 times the radius of that semicircle. So AF equals to 2 times the radius of the biggest semicircle. That is actually 2 times capital R. And according to what is given us the question, the length of line segment AF, that is the diameter of the biggest semicircle, it is equals to 140 degrees plus 70 degrees. 140 units plus 70 units. Again, AF equals to 140 units plus 70 units. So I write it down. AF equals to 140 units plus 70 units. 140 plus 70 is 210. So we found out that AF equals to 210 units and AF equals to 2 times capital R. It is 2 times the radius of the biggest semicircle. Here we will divide this equation by 2 and we'll get that capital R, that is the radius of the biggest semicircle, is equal to 210 over 2, that is actually 105 units. So capital R, that is the radius of the biggest semicircle, equals to 105 units. Okay. Here, point O is the center of the biggest semicircle. Point A is the point on the biggest semicircle itself. Therefore, that is exactly the definition of a radius. That is to say, AO is the radius of the biggest semicircle, that is equal to 105 units. Likewise, point O is the center of the biggest semicircle. Point F is the point of the biggest semicircle itself. Therefore, OF is also the radius of the biggest semicircle, that is equal to 105 units. Likewise, we know that line segment AC, according to what is given us in the question, equals to 140 units. But what is line segment AC actually? Line segment AC is the diameter of this semicircle. And therefore, the radius of this semicircle must be equal to half of it. So, if the diameter of this semicircle AB equals to 140 degrees, it means that the radius of this semicircle will be equal to half of it. 140 degrees over 2 is 70 degrees. So AB, that is the radius of this semicircle, equals to 70 units. And BC, it is also the radius of this semicircle, therefore it is also equals to 70 units. According to what is given in the question, line segment CF equals to 70 units. But what is line segment CF? Actually, line segment CF is the diameter of the smallest semicircle, and therefore the radius of this smallest semicircle will be equal to half of it. 70 over 2 is 35. Therefore, CE, that is the radius of the smallest semicircle, equals to 35 units. And EF, that is also the radius of the smallest semicircle, will be also equal to 35 units. What is the length of line segment BO? The length of line segment BO from a domain, it is very easy to see that BO equals to OA minus BA. Again, BO equals to OA minus BA. So BO equals to OA. OA equals to 105 units. It is the radius of the biggest semicircle. Minus BA. BA equals to 70 units. It's the radius of this semicircle. So, in conclusion, we found out that BO equals to 105 units minus 70 units. 105 minus 70 is 35 units. So, line segment BO equals to 35 units. You can write here that BO equals to 35 units. What is the length of line segment OC? The length of line segment OC, from the drawing, it is very easy to see that OC equals to OF minus CF. Repeat again. OC equals to OF minus CF. So OC equals to OF. OF is the radius of the biggest circle that is equal to 105 units. Minus CF. Here it is given us the question that CF, line segment CF, equals to 70 units. So in conclusion, we found out that OC equals to 105 minus 70 is 35 units. So OC equals to 35 units. Line segment OC equals to 35 units in its length. In the next step, I will present to you two new rules and we will implement the two new rules in our drawing. We have actually rule number 10. According to rule number 10, if two circles are touching each other internally, like in this drawing, we have the big circle touches this small circle, it's point N. Point N is the point of tendency or the touching point between the two circles. Then the straight line that connects their centers together, that is to say, the center of the small circle is at point M, the center of the big circle is at point O, and the straight line that connects their centers together is line segment MO. This line segment MO passes for their touching point. Their touching point is at this point, point M. That is to say, OMN is one straight line. Okay? So whenever we have an internal notch between two circles, like in this drawing, point N is the internal notch between those two circles, that is to say they are touching each other internally at point N. Then the straight line that connects their centers together, that is to say OM, passes through point N. That is to say OMN is one straight line. OMN is one straight line. And the distance between the centers of those two circles, that is to say OM, the length of line segment OM, is equal to capital R minus small r. Capital R is the radius of the big circle, small r is the radius of the small circle. So the distance OM equals to capital R minus small r. Here, D is actually equals to OM is equal to capital R minus small r. Likewise, we have also rule number 11. According to rule number 11, in this drawing, those two circles are touching each other externally at point N. So we have here an external notch between those two circles, and according to this rule number 11, if two circles are touching each other externally, like in this drawing, the touching point is at point N here, then the straight line that connects their centers together, that is to say the straight line OM, here point O is the center of the big circle, point M is the center of this small circle, and the straight line that connects their centers together is the straight line OM. This straight line OM must pass through point N, that is their touching point. Okay, here the straight line of actually the straight line OM that connects the centers together must pass through their touching point, that is actually point N. That is to say ONN is one straight line. And what is the distance between the center of those two circles? That is to say, what is the length of line segment OM? OM equals to capital R plus small r. Okay, D, that is actually OM, is equals to capital R plus small r. Okay, so we can implement the two new rules in our drawing. Here we will define the center of this circle as K, we will join the center of this circle, that is to say point K, with the center of this semicircle, that is to say point B. Okay, and here we have the circle have an external launch between this semicircle. That is to say, the circle touches this semicircle externally at point G. Therefore, according to rule number 11, the straight line that connects their centers together, that is to say, line segment KB must pass for their touching point. That is to say, it must pass from point G. That is to say, KGB is one straight line. KG is the radius of the small circle that is equal to R according to our definition. Why? Because point K is the center of the small circle, point G is the point of the small circle itself. This is exactly the definition of a radius. That is to say, KG is the radius of this circle that is equal to small r. We have already found out that the radius of this semicircle equals to 70 units. And here BG is the radius of this semicircle. Why? Because point B is the center of this semicircle, point G is the point of the semicircle itself. This is exactly the definition of a radius. So BG is the radius of this semicircle that is equal to 70 units, according to what is we've already found out. So BG equals to 70 units. And what is what is the distance between the centers of the semicircle and the circle? The distance is the radius of the semicircle, that is 70 units, plus the radius of the small semicircle, that is r. So in conclusion, we found out that bk equals to 70 plus r. bk equals to 70 plus r. I write it down. bk equals to 70 plus r units. Line segment bk equals to 70 plus r units. In the next step, we will join the center of the smallest semicircle, that is to say point E, with the center of the circle, that is point K. So the circle, the small circle and the smallest semicircle have an external knot between them at point H. That is to say, they are touching each other externally at point H. Therefore, according to rule number 11, the straight line that connects their centers together, that is to say KE, line segment KE, must pass for their touching point, that is point H. That is to say KHE is one straight line. Okay, KHE is one straight line. Point K is the center of this small circle. Point H is the point of the small circle itself. This is exactly the definition of a radius. So KH is the radius of this small circle that is equal to R. Point H is the point on the smallest semicircle. Point E is the center of this smallest semicircle. Therefore, HE is the radius of this smallest semicircle. We have already found out that the radius of this smallest semicircle equals to 35. So HE equals to 35 units. And in total, the distance KE between the centers of the smallest semicircle in the circle is r plus 35, or 35 plus r. So we can write down that KE, line segment KE, that is the distance between the centers of the circle and the smallest semicircle, equals to 35 plus r units. Repeat again, KE equals to 35 plus r units, and PK equals to 70 plus r units. What is the length of line segment VE? The length of line segment VE from the drawing, it is very easy to see that BE equals to BC plus CE. Again, BE equals to BC plus CE. BE equals to BC plus CE. So BE equals to BC. BC equals to 35 plus 35, that is 70, plus CE. CE equals to 35 units. So in conclusion, we found out that line segment VE equals to 70 plus 35 units. 70 plus 35 units equals to 105 units. So line segment VE equals to 105 units. In the next step, we will join the center of the biggest semicircle, that is to say point O, with the center of the circle, that is point K. We join points O and K together by a straight line. The biggest semicircle and this circle have an internal knot between them at point I. Whenever you have two circles or semicircles that have an internal knot between them, that is to say they are touching each other internally at point I, then the straight line that connects their centers together, that is to say OK, must pass through their touching point, that is actually point I. Or in other words, OKI is one straight line. OKI is one straight line. Point K is the center of the circle. Point I is the point of the circle itself. Therefore, Ki is the radius of this circle, that is equal to R. Point O is the center of the biggest semicircle. Point I is the point of the biggest semicircle itself. This is exactly the definition of a radius. That is to say, OI is the radius of the biggest semicircle, that is equal to 105 units, according to what we have already found out. Okay? So OI, that is the radius of the biggest semicircle, that is equal to 105 units, minus Ki, that is the radius of the smallest semicircle, is equal to OK. OK is the distance between the centers of the circle and the biggest semicircle. And whenever you have an internal knot between two circles, the distance between their centers, in this case it is OK, will be equal to capital R minus small r. Capital R is 105 and minus small r is unknown. So it is 105 minus r is the distance between the centers of the biggest semicircle, that is to say point O, and point K. That is to say OK equals to 105 minus R units. OK equals to 105 minus R units. Okay, in the next step, I will present to you a new rule, and we will implement the new rule in our drawing. We will implement the new rule in the green triangle KEB. Okay, we'll implement the new rule that I will present to you in the green triangle KEB. The new rule is called Stewart's Theorem. Stewart's Theorem is true in any triangle. So, the triangle that I will draw could be any triangle. This triangle ABC, could be any triangle. This is triangle ABC. We know that the length of side AB is equal to A units. Side AC equals to B units in its length. And side BC equals to C units in its length. And we have here line segment AO. This is line segment AO that is equal to D units in its length. In addition, we know that BO equals to M units in its length, and line segment OC equals to N units in its length. According to Stewart's theorem, the following equation is true: that A squared times N plus A squared times N plus B squared times M. M is the length of line segment BO, and N is the length of line segment OC. So A squared times N plus B squared times M equals to C. C is the length of line segment, the length of the side BC. C times D squared, again D is the length of line segment AO, plus M times N. Okay? Repeat again, in any triangle, A squared times N plus B squared times M equals to C times D squared plus MN. And this equation is true in any triangle. Therefore, we can implement Stewart's theorem in our green triangle BKE. We'll implement the Stewart's theorem in the green triangle BKE. So I'll copy the angle BKE in a new page and we'll implement on it Stewart's theorem. Side BK equals to BG plus GK. BK equals to BG plus GK, that is to say it is 70 plus R. Side KE of this green triangle KBE KE equals to K edge plus AG. K edge is R, edge E is 35, so it is 35 plus R. KE, side KE equals to 35 plus R. The length of side BE equals to BO plus OE. BO equals to 35 units and OE equals to 35 plus 35. That is to say BE equals to 35 plus 35 plus 35, that is 105 units. So this is actually triangle KBE, the green triangle that I copied from the original drawing. And finally, line segment KO equals to 105 minus R units. Repeat again. Line segment KO equals to 105 minus R units. Line segment BO equals to 35 units. And line segment OE equals to 35 plus 35, that is 70. Okay, now we can implement Stewart's theorem in this triangle KBE. So in this triangle KBE, according to Stewart's theorem, we get that BK square times OE. BK is 70 plus R, and therefore BK square is 70 plus R square times OE. OE is 70, so this time 70 plus KE square times BO. KE is 35 plus R, therefore KE square is 35 plus R square. KE square times BO is 35, therefore we substitute BO by 35 is equal to BE is 105, and inside the brackets we have KO square. KO is 105 minus R, therefore KO square is 105 minus R square plus BO times OE. BO is 35 and OE is 70, so it is 35 times 70. So actually this equation, it is the implementation of Stewart's theorem in our triangle KBE. We will define 35 as x and we'll substitute this equation 35 or the multiplication of 35 by x. Okay, so we have 70 is 2 times 35, that is to say it is 2x plus r times 70. 70 is 2 times 35, that is to say it is 2x plus 35, we substitute 35 by x, it is x plus r square, here it is also square, 35 is x, so we substitute 35 by x, and it is equal to 105, 105 is 2 times 35, that is to say it is 3x, and inside the brackets we have here, again 105 is 3x, minus r square plus 35 is x and 70 is 2x. So it is x times 2x, all under the brackets. Here we will divide this equation by x. So here x will get cancelled. Here x will get cancelled. And also x will get cancelled. So what is left of this equation after we cancelled x? We have 2x plus r squared times 2 plus x plus r squared and it is equal to 3. Inside the brackets we have 3 times 3x plus r squared plus x times 2x is 2x squared plus 2x, all under the brackets. So we have here 2x plus r squared equals to 2x squared, that is 4x squared, plus r squared plus 2 times 2x times r, 2 times 2x times r is 4xr, plus x plus r squared is x squared plus r squared plus 2xr, and in the other side of the equation we have 3. We will open the bracket inside, we will open the brackets inside this expression. So here we have 3, and inside the brackets we have 3x plus r squared. 3x plus r squared equals to 3x squared, that is 9x squared, plus r squared, so 3x minus r squared. So it is 3x minus r squared. 3x minus r squared equals to 3x squared, that is 9x squared plus r squared minus 2 times 3x times r. 2 times 3 is 6, so it's, in total it will be equal to minus 6xr plus 2x squared. So we'll open the brackets here. 2 times 4x squared is 8x squared plus 2 times r squared is 2r squared. 2 times 4xr is 8xr plus x squared plus r squared plus 2xr is equal to 3. Here we have inside the brackets 9x squared plus 2x squared is 11x squared plus r squared minus 6r. Okay, so here we have 8x squared plus x squared is 9x squared. We have here 2r squared plus r squared is 3r squared. And we have here 8x squared plus 2x squared, it is 10x squared, 10xr. 8xr plus 2xr is 10xr. And in the other side of the equation we have 3 times 11x squared is 33x squared. 3 times r squared is 3r squared. And 3 times minus 6r is minus 18xr. Okay. So here we have 3r squared on both sides of the equation, so 3r squared will get cancelled. In the next step, we will subtract 9x squared from this equation. Minus 9x squared. So 9x squared will get cancelled. And 33x squared minus 9x squared is 24x squared. So 10xr equals to 24x squared minus 18xr. Repeat again, in conclusion, we found out that 10x squared equals to 24, 10xr equals to 24x squared minus 18xr. We will add to this equation 18xr, and we get that 10xr plus 18xr is 28xr, and 28xr equals to 24x squared. Here we will divide this equation by x. X is a positive number, therefore it is allowable to divide this equation by x. It is not 0. So 20xr minus x is 28r, and 24x squared over x is 24x. In conclusion, we found out that 28r equals to 24x. Here we'll substitute x by 35, and we'll get that 28r equals to 24 times x is 35. So here we will divide this equation by 6. We will divide this equation by 7. 28 over 7 is 4. So in this side of the equation we have in total 4r. And this is equal to 24. 35 over 7 is 5. In this side of the equation we have in total 24 times 5. Here we will divide this equation by 4. 4r over 4r. 4r over 4 is r. And 24 over 4 is 6. So in total, in this side of the equation, we have 6 times 5. R equals to 6 times 5. 6 times 5 is 30. So R equals to 30 units. So finally, we found out that the radius of this circle R equals to 30 units. Okay, in the next step I'll summarize the lecture. In the drawing, we have a big semicircle. Inside this big semicircle, we have 2 semicircles and a circle. It is given us the equation that line segment AO equals to 140 units and line segment OF equals to 70 units. Line segment AC, this line segment AC equals to 140 units, and line segment CF equals to 70 units. And our mission is to find out the radius of this small circle. So we defined capital R. Capital R is the radius of the biggest semicircle, and small r is the radius of this circle. Okay? Again, capital R is the radius of the biggest semicircle, and small r is the radius of the circle. It is given as the equation that the length of line segment AF, it is 140 units plus 70 units. 140 plus 70 is 210. So AF equals to 210 units. But what is AF? AF is the diameter of the biggest semicircle. AF is the diameter of the biggest semicircle, and the diameter of any circle or semicircle is twice as long as the radius. So we define the radius of this biggest semicircle as capital R. Therefore, AF will be equal to 2 times capital R. AF equals to 2 times capital R is equal to 210 units. Okay, so AF equals to 210, that is equal to 2R. Here we divided this equation by 2, and we got that capital R, that is the radius of the biggest semicircle, equals to 210 over 2, that is 105 units. So we found out that the radius of the biggest semicircle, F equals to 105 units. Here, OA, that is also the radius of the biggest semicircle, is equal to 105 units. Okay. Then we actually have, we know that line segment AC equals to 140 units according to what is given as the equation. But what is line segment AC? Line segment AC is the diameter of this semicircle, and therefore the radius must be equal to half of it. That is to say, the radius AB must be equal to 70 units, and the radius BC must be also equal to 70 units in its length. Likewise, it is given as the equation that CF equals to 70 units, but CF is the diameter of this smallest semicircle. So if the diameter equals to 70 units, then the radius of this smallest semicircle must be equal to half of it, that is 70 over 2 is 35. So the radius CE equals to 35 units, and the radius EF, it is also equals to 35 units. And what is the length of line segment BO? From the drawing, it is very easy to see that BO or OB equals to OA minus BA. OA minus BA equals to BO. Repeat again. BO equals to OA minus BA. OA is the radius of the biggest semicircle, that is 105 units. Minus BA is the radius of this semicircle, that is equal to 70 units. And therefore OA minus BA, it is 105 minus 70 units. So BA or BO equals to 105 minus 70, that is 35 units. So we found out that BO equals to 35 units. Then we found out the length of this line segment CO. From the drawing, it is very easy to see that CO or OC equals to OF minus CF. Again, OF minus CF equals to OC. Repeat again. OC equals to OF minus CF. OF is the radius of the biggest semicircle, that is 105 units. Here, CF equals to 70 units, it is the diameter of the smallest semicircle. And therefore, OC equals to OF minus CF, that is actually 105 minus 70. 105 minus 70 is 30, it is 35. So we found out that the length of line segment OC equals to 35 units. Okay. Then I presented to you two new rules and implemented the two new rules in our drawing. According to rule number 10, if two circles are touching each other internally, that is to say those two circles have an internal line between them. Here the small circle is inside the big circle, therefore they are touching each other internally at point N. Point N is the touching point. So if we have, like in this drawing, two circles that are touching each other internally, then the straight line that connects their centers together, the center of the small circle is at point M, and the center of the big circle is at point O. And the straight line that connects their centers together is line segment MO. This line segment MO or OM must pass through their touching point. Their touching point is at this point, point N. That is to say, OMN is one straight line. Okay, OMN is one straight line, and the distance OM between their centers is equal to capital R, that is the radius of the big circle, minus small r, that is the radius of the small circle. So the distance OM, D, equals to capital R minus small r. Likewise, if we have two circles that are touching each other externally, like in this drawing. Those two circles are touching each other at point N externally. Then the straight line that connects their centers together, that is to say the straight line OM, must pass for their touching point, that is actually point N. In other words, O and M is one straight line. O and M is one straight line. And what is the distance between their centers? OM. OM equals to capital R plus small r. The distance OM between their centers equals to capital R plus small r. So we actually can implement the two new rules in our drawing. And because in our drawing we'll connect the center of this semicircle, that is to say point B, with the center of this circle, that is to say point K. So we'll connect the 2 points B, K by a straight line. The semicircle and this circle have an external between them at point G, and therefore the distance between their centers BK, or the straight line that connects their centers together BK, must pass for their touching point, that is actually point G, or in other words, BGK is one straight line. Okay, so BG is the radius of this semicircle, that is equal to 70 units. GK is the radius of this small circle, that is equal to R. Therefore, the distance BK between their centers is 70 plus R. Okay, so BK equals to 70 plus R units. As you can see here, BK equals to 70 plus R units. Then we connected the center of the smallest semicircle, this is actually point E, with the center of this semicircle, that is to say point K. Okay, and the straight line that connects their centers together is KE, must pass for their touching point, that is actually point H. That is to say EHK is one straight line. Okay, they have an internal knot between them at point H, an external knot between them at point H. That is to say, they are touching each other externally at point H, and therefore the straight line EK that connects their centers together must pass for their touching point, that is to say for point H. That is to say EHK is one straight line, and therefore EH is the radius of this smallest semicircle, that is 35 units, and HK is the radius of this small circle, that is equal to R. And therefore, in total, EK equals to EH plus HK. That is to say, EH equals to 35 plus R units. Okay. EK, the length of this line segment EK, equals to the radius of this smallest semicircle, that is 35, plus the radius of this circle, that is R. So KE in total equals to 35 plus R. And what is the length of line segment BE? From the drawing, it is very easy to see that BE equals to BO plus OE. BO equals to 35 and OE equals to 35 plus 35. That is to say, BE equals to 35 plus 70. So we found out that BE equals to 35 plus 70, that is 105 units. Okay, BE equals to 105 units. And finally, we connected the center of the biggest semicircle, that is to say point O, with the center of this circle, that is actually point K. And the biggest semicircle have an internal between this circle, that is to say, they are touching each other internally at point I. And therefore, the straight line OK that connects their centers together must pass through their touching point, that is actually point I. Or in other words, OKI is one straight line. Okay, OKI is one straight line. And what is the length of line segment OK? The length of line segment OK equals to the radius of the biggest semicircle, that is OI, minus the radius of the small circle, that is R. Okay? But OI, the radius of the biggest semicircle, is 105 units, and the radius of the small circle is R. So in total, we found out that OK equals to 105 units minus R. Here, OK equals to 105 units minus R. In the next step, I presented to you a new rule. It is actually Stewart's theorem, and we implemented the new rule in our green triangle, triangle BKE. According to Stewart's theorem is true in any triangle. So if we have triangle ABC here, that could be any triangle, and we know that the length of side AB is A units, side AC equals to B units in its length, and side BC equals to C units in its length. In addition, we know that line segment AO equals to D units in its length, line segment BO equals to M units in its length, and finally line segment OC is equal to N units in its length. Then, according to Stewart's theorem, the following equation will be true. A squared times N plus B squared times M, A squared times N plus B squared times M equals to C, and in the brackets we have D squared plus M times N. Okay, so A squared times N plus B squared times N equals to C. Inside the brackets we have D squared plus M times N. We can implement Stewart's theorem in our triangle BKE. So I copy the green triangle BKE in a new page, and we implemented here Stewart's theorem. This is triangle KBE that I copied from the original drawing. KB equals to 70 plus R, K equals to 35 plus R, P equals to 105 units, KO equals to 105 minus R units, line segment BO equals to 35 units, and line segment OE equals to 70 units. And implemented here Stewart's theorem. According to Stewart's theorem, the following equation is true. That KE squared times BO, KE is 35 plus R, and KE squared is 35 plus R squared, times BO. BO is 35, so we substitute BO by 35, plus BK squared times OE. BK or KB is 70 plus R, therefore BK squared is 70 plus R squared times OE. OE is 70, so we substitute OE by 70. So in this side of the equation we have 70 plus R squared times 70 plus 35 plus R squared times 35 equals to BE. BE is 105, so we substitute BE by 105. And inside the brackets we have KO squared KO is 105 minus R, therefore KO square is 105 minus R square, plus BO times OE. BO is 35 and OE is 70. So we substitute BO times OB by 35 times 70. So in conclusion, we found out that 70 plus R squared times 70 plus 35 plus R squared times 35 was 205. Inside the brackets we have 105 minus R squared plus 35 times R. Then we substituted 35 by X in this equation. So here, this is the implementation of the Stewart's theorem in our triangle KBE. In the next step, we substituted 35 in this equation by X. Okay, whenever we have 35, or the multiplications of 35, we substitute it by X. So here 70 is 2 times 35, so it is 2x plus R squared times 70 is 2 times 35, this is actually 2x plus 35 is x plus R squared times 35 is x. Okay, in the other side of the equation we have 105 is 3 times 35, that is to say it is 3x. And inside the brackets we have again 105 is 3 times 35, that is 3x, minus R squared, plus 35 is x, and 70 is 2x. 70 is 2 times 35, that is 2x. Here we divided this equation by x. After we divided by x, we found out that 2 times 2x plus R squared plus x plus R squared equals to 3. And inside the brackets we have 3x minus R squared plus, here we have x times 2x is 2x squared. Then we open the brackets here, 2x plus R squared, we have 2 times, inside the brackets we have 2x plus R squared. 2x plus R squared equals to 2x squared, that is 4x squared, plus R squared, plus 2 times 2x times R is 4xR. All the multiplied by 2, and here we have x plus R squared. X plus R squared equals to x squared plus R squared plus 2xR. In the other side of the equation we have 3, inside the brackets we have 3x minus R squared. 3x minus R squared equals to 3x squared, that is 9x squared, plus R squared, minus 2 times 3xR is minus 6xR, plus 2x squared. Then we open the brackets here. 2 times 4x squared is 8x squared. And we have here 2 times R squared is 2R squared. And 2 times 4xR is 8xR. Plus x squared plus R squared plus 2xR. It is equals to, inside the brackets we have 2x x squared plus 9x squared is 11x squared, and we have also plus R squared minus 6xR. Okay, so here we have 8x squared plus x squared is 9x squared, and 2R squared plus R squared is 3R squared, and here we have 8xR plus 2xR is 8xR. So in total, in this side of the equation, we have 9x squared plus 3R squared plus xR equals to, we open the brackets on the other side of the equation, and we have here 3 times 11x squared is 33x squared, and 3 times R squared is 3R squared, and 3 times minus 6R is minus 18xR. In the next step, we subtracted, we have 3R squared on both sides of the equation, so 3R squared will get cancelled. In the next step, we subtracted 9x squared from this equation. 9x squared minus 9x squared is 0. In the other side of the equation, we have 33x squared minus 9x squared is 24x squared. So we have 24x squared minus 18xr equals to 10xr. Here we added 18xr to this equation and found out that 10xr plus 18xr is 28xr. On the other side of the equation we have 24x squared. So in conclusion we found out that 28xr equals to 24x squared. Here we divided this equation by x. 28xr over x is 28r, and 24x squared over x is 24x. So we found out that 28r equals to 24x. Here we substituted x by 35 and found out that 28r equals to 24 times 35. Here we divided this equation by 7. 28 over 7 is 4, so this expression in total equals to 4r. And 35 over 7 is 5, so this expression in total equals to 24 times 5. Here we divided this equation by 4, so 4r over 4 is r, and 24 over 4 is 6. So this expression in total equals to 6 times 5. In conclusion, we found out that r equals to 6 times 5. 6 times 5 is 30. So r, the radius of the circle that we are looking for, equals to 30 units in its length. Here, the radius of this circle, r equals to 30 units. Okay, thank you very much.